All right, guys, so this next video deals with reference angles and something called their cofunction. So that's what we're going to talk about today. So back in the old days, they didn't have a graphing calculator, and so they would use something called trig tables to get like sine and cosine and tan for angles. But they would only do it, the table itself would be written through 45 degrees. So how did students use those if we had angles that were bigger than 45 degrees? So for example, here's what the trig table kind of um, looks like. Now, they didn't have these degrees written here, but we'll talk about that in a second. So like, for example, if I wanted to find the sine at 5 degrees, I would do sine of 5 degrees. Okay, and then I could do cos and tan, and I could do the reciprocals. But this chart would only go up to 45. But what we notice is if we look at the bottom, we also have these guys, which relate here. So like I can also do the cos of a 50-degree angle. And the cos of a 50-degree angle, let's see, cos of 50 degrees is 0.6428. But that's also the same as this column was sine of a 40. So what we're noticing is that the sine of 40 degrees, it gives me the same thing as the cos of a 50-degree angle. And so the question is, how is that? What's happening here? And then we also realize that the same thing happens with tan and cotan and sec and cosec and so on and so forth. So what's happening that's causing that? Okay, so let's draw a basic triangle and see what happens. So I'm just going to draw my arbitrary 30, 60, 90 triangle, and we'll label it. We'll go ahead and just put it on the unit circle. So that's 1, this side's 1/2, and this side is √3/2. So if I want to take the cosine of the 30-degree angle, that would be adjacent √3/2 over hypotenuse. So √3/2. Okay, now if I wanted to use the 60-degree angle, but I still wanted to use those two sides, the √3/2 and the 1/2, now it would be the what of 60, because the √3/2 is opposite, the sine. So the sine of 60 is still going to give you the same side of the triangle over that as the cosine of the 30 did. So what we notice here is that, and let's do one more just in case. So let's say that we had, 42, and this guy would have to be 48. Okay. So same thing. If I had, I'm just going to put x, y, and r for radius. If I wanted the sine of the 42-degree angle, that would be y over r. And if I still want to use y and r, but use the 48 instead, the y would now be adjacent and the r would be hypotenuse, which would be the cos. So what we notice is that you end up with the same relationships, except you're using this complementary angle. So if I want to do, if I want to use sine and cosine to get the same thing, I have to use the complementary angle. So what we're noticing here is that these two values are just, complements of each other, meaning 90 minus that value. So like if I want to do the sine of 42, that'll be the same as the cos of 48, which is bigger than that 45. Okay, so because of this takes it down to it makes it easier, because then that means that I can, anything that's bigger than 45, I could technically go, oh, well, the complement is 30, so instead of sine, let's just do cosine, and then you can do it of a smaller angle, right? Okay, so that's kind of the idea. So these functions that have this relationship where they're the same thing if you do the complement, these are called cofunctions, right? So that's where, if you've ever wondered why it's sine and cosine, or tan and cotan, or secant and cosecant, that's where that relationship comes from. They're basically the same functions, they're just of the complementary angle. So once again, I have it listed here, but if I take the sine, let's see if I can make this just a little bigger. There we go. There we go. So if I want to do, if I know that I have the sine of 90, that will be the same thing as the cos of the complement of that angle. So 90 minus that angle. Or if I have sine of 90 minus theta, that'll be the same thing as just cos of theta, because these are complements of each other and these are cofunctions. So one more time, like if I have the tan of 72 degrees, that will be the same as the cotan, but of the complement. So this would give you the same thing if you had the cotan of 18 degrees. Okay. So again, it allows us to take relationships that are much larger and then, change them into something much more manageable. So that's what we're going to work on today. We're going to work on, well, how do we find that, right? Like, how do we get these weird ones? And so we're gonna come up with ways to take any angle and any trig function and get it down to something that's between 0 and 45. So in this case, I'll also be doing it in radians. So that would mean I can express every angle as a function between 0 and pi over 4. So that's going to be our plan today, is to try to take any angle that we're given and do that. Okay, so I'll just do it by going through an example with you guys, and then we'll do a few examples together. Okay, so this first one, let's do the cosine of, I'll do a degrees first, and then I'll do a radian. So let's do the cosine of a 248 degree angle. And my goal will be able to get this down to something that is the trig operation of something that's 0 to 45, right? So that's my plan. Okay, so the first step would be to lop off any xx rotations. So if I was bigger than 360 or bigger than 2 pi, I would do that. But I already am, so I'm good on this one. I'll make the next one bigger. Okay, so the first thing you would do is get it down to a manageable 1 rap. Okay, then once you're down to 1 rap, figure out the quadrant in which this angle is located. So let's see. 248 is bigger than 180 but less than 270. So it's down here in the third quadrant. Okay, this I need for parity, meaning what sign is it? And then the reference angle, so I need to figure out the reference angle of 248. So if I were to make that, drop that perpendicular to the x-axis, I want to know this little reference angle in here, right? So the reference angle will be how much it differs from the x-axis. So in this case, how far is this from 180? I can do 248 minus 180, and I can see that the reference angle there is 68. So my little reference angle is 68 degrees. Okay. So now we're definitely, we've taken our angle down to something that's at least from 0 to 90. So we're getting closer to 0 to 45. Now, here's my question. This is the same as the cos of a 68 degree, except you have to check here. Would the cosine, which is x, be negative or positive? What's the parity in this quadrant? Cosine should be negative in this quadrant. So that means you need to put the negative here, because remember, when you take it down to something that's between 0 and 90, this angle is now in the first quadrant, which means it's always positive. So if it was supposed to be negative, you have to force it to be negative. Okay. So now we're closer. Okay. Last question is this angle small enough? So is this less than 45 or less than pi over 4? No. If it's yes, you're finished. If it's no, then we have to do two things. One, we have to convert it to the cofunction, and then two, we have to convert the angle. So what I mean by that is, what is the cofunction of cosine? Sine. So the first thing I'm going to do, don't lose the negative, is change it to sine, but then remember, it would be the sine of the complement. So you're going to have to do 90 minus that. So then I get sine of 22. So woo, all the way from the very beginning, that was the exact same thing as negative sine 22. Let's do another one. I'll do it on the same page, but this one I'll do in radians. So let's do secant, and let's do of 24 pi over 7. Whoa, crazy. Okay, so the first thing we have to do is get rid of any extra rotations. So let me think. 2 pi, if I'm in sevenths, would be 14. So I don't want to be anything bigger than 14 pi over 7. So I'm going to have to take out full wrap. So I'm going to take 24 pi over 7, and I'm going to subtract 2 pi, but it's 14 sevenths. So then I get 10 pi over 7. Okay, that's less than a full circle. So I've lopped off excess stuff. So now this is the exact same thing as secant of 10 pi over 7. Same exact angle. Okay. Second part, now that we've taken it down to 1 rap, determine which quadrant we're in. So where is 10 pi over 7? Well, let's see. This is pi, which if I was in 7th would be 7 of them. Remember, this is 14. So then it's somewhere in between here, but maybe you're having trouble figuring out, is it here in the third or is it here in the fourth? Well, you can easily figure that out, because this guy, the halfway point between these two, right, between 7 and 14, you could just find the average of 7 and 14. So the halfway point of this This guy would be 10.5 pi over 7. So now it's real easy to tell. Oh, well then that means 10 pi over 7 must be here. So one more time, I had to find the halfway point, which would be like this 270. And then that's how I could figure it out. Okay, so once I do that, now I know it's in the third quadrant. I want to find the reference angle. So if this is 10 pi over 7, how much further did I go? If you have this marked, it's real easy because you just went 3 pi over 7 further. So that means that this is the same as the secant of 3 pi over 7. Now, don't forget to check for positive or negative. Secant is the reciprocal of cos, so is cos positive or negative here? Yep, negative. Okay. Now, last but not least, you have to ask yourself, is 3 pi over 7 small enough? Right? I would just do the decimal. Like I would just see if I would compare 3/7 and 1/4 and see if 3/7 is bigger than 1/4. And guess what? It is. This is like 0.42-ish, which is definitely bigger. If it's bigger, then you have to convert. If it was smaller, then we would just be done. So what do we have to do to convert? We keep the negative. What's the cofunction of secant? Cosecant. And then I have to do the complement of the angle because that's the whole point. I'm switching the angle. So remember, if I'm in radians, instead of 90, it's going to be pi over 2 minus the angle. And the angle was 3 pi over 7. So then I get negative cosec. I would change these both into 14ths. So this will be 7/14 times 2 would be 6/14. So I end up with pi over 14. So this is the same as that original one. Let's just do one more. Okay, so let's do, let's see. I'm just pulling them up. So we haven't done a cotan yet. So let's do a cotan, and let's do of 71 pi over 5. We'll see where this guy lands. Who knows? Okay. So the first thing we have to do is figure out lop off any extra rotations. So I'm going to take out 2 pi, which if I'm in fifths would be how much? 10 pi's. So I'm going to take out chunks of 10 pi. So literally I'm going 71 pi over 5 minus 10 pi over 5 minus another 10 pi until I get it down to something that's manageable. So let's see what I get here. I think that this guy will go all the way down to pi over 5. Ooh, this is actually an easy question. We'll have to do 2 examples. I was able to take out 7 of these wraps. So that means this is the exact same thing as cotan of pi over 5. Okay. So then normally what I would do next is go, okay, well, what quadrant is pi over 5 in? So pi over 5 is in the first. The nice thing about being in the first is that that is the reference angle. So you didn't have to change it. So it literally stayed the same. And then the last question is pi over 5 smaller than pi over 4? Hey, it is. So that one, we were actually already done. What? That was an easy one. I got to work harder. Let's try a harder one. So let's do another cotan. Let's see if I can do better this time. Instead of 71, let's do 78 pi over 5. I'm going to make it a little harder. So 78 pi over 5. All right, let's take out tens, right? So 10 pi over 5. So I'm going to take out 2 pi or 10 pi over 5. This one, if I lopped it off, would come down to just 8 pi over 5. Okay, there, that's a little more fun. Okay, so we have cotan of 8 pi over 5, which gets me to the exact same place as 78 pi over 5. Okay. Now, we have to determine where this is. Which one of the 4 quadrants? So, okay. This would be, I'm in fifths, so pi is really 5 pi over 5, guys. 2 pi is 10 pi over 5. So I know that 8 pi over 5 is somewhere in between these. The question is just where. So this is where I'd figure out what the halfway is. The halfway between 5 and 10 is 7.5. So then I know for sure that the 8 pi over 5 would land me here. Okay. Drop the little perpendicular and get the reference angle. Well, if this is 8 pi over 5, then you're 2 pi over 5 from the x-axis. So this is the same as cotan of 2 pi over 5, but wait, you got to check positive or negative. Don't forget that. Should cotangent be positive or negative here? Cotangent should be negative in the fourth quadrant. So then you need to force it to be negative. Otherwise it won't. Okay. And then last but not least, now that I've taken it down to something that's less than 90, I need to see if 2 pi over 5 is less than pi over 4. So I'm going to compare these two things. Remember, just use the fractions. 2/5 compared to 1/4. This is 0.4. This is 0.25. This is still too big. So if it's too big, you have to do two things. Switch it to the cofunction, tan, and then you need to use the complement, which is 90 minus this, or since I'm in radians, pi over 2 minus this. And so I'd change them both to tenths. So times 5, times 5, times 2, times 2. So then I get 5 pi minus 4 pi, so I end up with negative tan of 1 pi over 10. So your worksheet is literally you converting these. Sometimes it doesn't take much work, and sometimes it takes a lot of work. So feel free to watch these a couple times. We'll talk about them in class, and I'll see you then.